Okay, dear students, let us see what are we going to do in this video. So, what are we going to do? First of all, we are going to learn three things in this video. The point number one is that we are going to learn about the relation between angular velocity, frequency, time period, and all, and we would be and try to relate them, try to understand what is this. Okay, what are these things? Now, point number two is we will go into centripetal force concept. And the point number three is there is again a force which is called centrifugal force. So I would be telling you about the centrifugal also in this topic. Okay, so let us talk about this first of all. Okay, so in the last video we did the angular velocity, and we draw the circle, and now you know what angular velocity is. So angular velocity is omega, and this is actually defined as delta theta by delta t. So technically the unit is radian per second, so we can define angular velocity as the rate at which the angle is being traversed, isn't it? So omega is equal to delta theta by delta t. In what, how much time are you going to cover, how much angle? So let us now concentrate on the complete circle. So if let us say this is one complete circle and there is a bob here, this is moving with the tangential velocity of vt, there is an angular velocity of omega, and it would be coming back to the same point again once, and completing one circle once. So what is the angle that it is traversing? 2 pi. And the total time taken by that can be written as capital T, because capital T is always, like the total time. So by the definition, we can say that omega is equal to 2 pi, the total angle, and the total time taken is t. And thereby, omega is equal to 2 pi by t. We have created a formula for ourselves. So if the omega is given, you can find the total time. If the total time period is given, we can find the omega. Now, 1 by t is the frequency, so this can also be written as 2 pi f, because the frequency f is defined as 1 by t. Be very particular now, the time is in the seconds and this frequency is in the hertz. So we are relating it to the frequency now. But before we go to the frequency, let us talk here again. Like if we are concentrating on omega is equal to 2 pi by t, and we are talking in the terms of circular motion, we call this as angular velocity. But if we talk in the terms of simple harmonic motion, at that time, the same thing is called angular frequency with the same unit. Like angular velocity, the unit can be taken as radian per second, which can also be written as just per second. Angular frequency is written as per second. Okay, so they are technically the same thing, they have the same unit, everything. But when you talk about a circular motion only, we name it as angular velocity. But when we talk about simple harmonic motion, or we are trying to relate it with the frequency, so we start calling this as angular frequency, although they are the same things. So angular frequency and angular velocity does not have any difference. So omega angular frequency is equal to 2 pi f. That's it. Clear? Where f is the frequency, the unit of this frequency is hertz, unit of this frequency is kind of radian per second or just per second, that depends. Okay, so this is about the relationship between the time period omega and f, and I have told you that. Now very quickly moving to the next topic, which is the centripetal force. Now, so what is the centripetal force? Now, first of all, we will try to understand the concept of centrifugal force. Okay, let us say this is the circular motion. Okay, this body is moving. Now at this particular location, the velocity is v1 at this particular location. Let us say at this particular location, now the velocity is this, which is v2. If I say that the magnitude of v1 and v2 does not change, it is moving at 30 kilometers per hour speed, and it was moving at this speed, it is moving at its speed, so there is no problem in the magnitude, it is still 30 km per hour. But still, won't you say that the velocity has changed? Because velocity is not only the magnitude, it is the direction. Velocity is a vector which depends on the magnitude as well as direction. So if magnitude is not changing but the direction is changing, even then we have to say that the velocity has changed. So this velocity is not same as this velocity. Now how do you define the acceleration? Acceleration is defined as rate of change of velocity, which means delta v divided by delta t. So I'm using vector notation here, although that is not required from IB point of view, but if we are using this, this becomes more elaborative and more understandable. Like, we are not interested in finding the difference in the magnitude, but we want to find the difference in the direction. It's kind of north minus west. But anyways, so delta v divided by delta t. Now, if there is a change in velocity, yes, there is a change in velocity. So we will say v2 vector minus v1 vector divided by the time. So that will give you an acceleration. Now this acceleration is not about the magnitude, but it is only and only about the direction. Such an acceleration is called centripetal acceleration. Now let us consider this circle here. Okay, uh, just a moment. Yes, yes. Now, so this is the circle that the bob is now moving. And these are the 2 points, reference points that we have chosen. One point is P, another point is Q, and the angle is given, that is delta theta. So the distance between this is L is equal to R delta theta, no problem about that. So this is the velocity which is Vp, and this is the velocity which is Vq, and both of the velocities are not equal to each other because they have the different directions. But yes, they have the same magnitude, so we can just call them V also. So you call it Vp or Vq or V, one is the same thing. Now what we do is we create a velocity diagram here about Vp and Vq only. So this Vp is drawn like this and Vq is drawn like this. You can move these vectors parallelly in a plane without changing the direction or changing the magnitude. The vectors can be moved around in any plane. So these two vectors have been moved around and we have now arranged them tail to tail, we can say, isn't it? Like tail to tail, this is the tail of a vector, so they are connecting tail to tail. Anyways, not going into deeper details for the vectors, not required. So now if we want to subtract it, like vq minus vp in the terms of vectors, please try to remember maths AAHL vectors that you, whatever you have done till now. If there is a subtraction, we just draw a line from P to Q. So this is P end and this is the Q end. So we would be drawing the vector from P to Q, and this vector will be referring to the change in the velocity vector. Okay, I hope you know this thing. If we are going to add them, it is this diagonal of the parallelogram. If we subtract them, it is this diagonal. So that is the relation that we are using it here. So this becomes delta v. Now this is delta v. So this delta v is now approximately equal to the arc length, isn't it? Like this arc, we can just imagine that there is a circle here, and we can say that this arc length is approximately equal to delta v, provided delta theta is very, very small. So here we are using L is equal to R theta. What is the length? Length will be taken as delta v because the length of arc here is approximately equal to change in velocity. So L is equal to R theta. Now the radius is the V here. The magnitude is V and the angle is delta theta. Now we have the formula for the change in velocity, and our centripetal acceleration was defined as change in velocity divided by change in time, provided like there is no change in the magnitude. So we are going to substitute this value here. It will become V delta theta divided by delta t. You can even skip this arrow, no problem. So we are creating a formula which is the centripetal acceleration is equal to V into omega, and V is equal to R omega, so you can call it R omega square, or omega can be written as V by R, so that will become V square by R. We are using the formula V is equal to R omega in this. So there are three formulas for the centripetal acceleration that we have created. Although this formula is the most usable in IB, till now I have not seen many questions using these formulas, although they are the same, like just substitution of V is equal to R omega, you can get these formulas. So this is V square by R. So centripetal acceleration is V square by R. So this is about the magnitude of the centripetal acceleration. What about the direction? Now, when we talk about direction, we will go to see the vectors now. So here it clearly says that the direction of the acceleration is same as that of the direction of change in velocity. So the change in velocity is like this. So it is actually pointing towards the center of the circle. It is pointing towards the center of the circle. So I'm writing here that the direction of centripetal acceleration is always towards the center of the circle. Always towards the center of the circle. Wherever it is, if it is at this position, the acceleration is downward. If it is at this position, it is like this. This position, it is like this position, it will be upward. So wherever you go, the direction of the centripetal acceleration is always towards the center, and because of this force only, because of this acceleration only, the direction has been changed. You can just imagine that there is a person running, and he is running by here, and you are now pushing him at 90-degree angle. What will happen? He will change the direction. If you're pushing at 90-degree angle, he will change the direction. Yeah, he will fall after some time, but anyways, he will change the direction. So that is the centripetal force, and we would be going to the force also sooner. So this is the centripetal acceleration, nothing else in this topic of the centripetal acceleration. But now let me tell you about the two things. So this is another part of the video. Now I am moving into the topic of centripetal force and centrifugal force. Okay, I'm erasing these things here now. Yes. Now, the centripetal force. Now, this is written as Fc. Now, because Newton said that F is equal to m into A, so we will just use it, and the acceleration is substituted as V square by R. It becomes mv square by R. So, the centripetal acceleration becomes centripetal force becomes mv square by R, the magnitude of the force, and this force is always acting towards the center. So, this is the centripetal force. Now, what about the centrifugal now? I'm writing centrifugal as this. This topic is very important, very special. Try to listen to this very carefully. Now, what is happening in this is centrifugal force is also a very important force. Let me explain you first, then I will tell you those things. Okay, so centrifugal force is a counter force now. So when this bob is rotating in the circle here, if I tell you that okay, there is a force which is acting here towards the center, so your next question could be why the point P is not going towards the center of the circle. Why it is not going towards the center of the circle then? Because if there is an attraction between them, why it is not going towards the center of the circle? And that is because there is a counter force here which is called centrifugal, which is the reaction part of centripetal force. So centrifugal is the reaction part of centripetal. Thereby it means that they are equal in magnitude but opposite in direction. So centrifugal force is directed always, like always directed away from the center, and centripetal force is always directed towards the center. So these are action reaction pairs. So we can say that this force is technically cancelling this force, and that is why both of these forces are kind of like they are balanced. So the body is not going inside towards the center. This is the like we can just imagine in this. But now I am going to tell you another uh, very important point here. Point to be noted: both of these forces are fictitious. Centripetal force also and centrifugal force also, they do not actually exist. Centripetal force is, it does not have its own existence. One or the other force has to act like centripetal. Like for example, if I take the example of the earth and moon, so the gravitational force of attraction between the earth and the moon is acting like centripetal force in the case of moon, and that is why the moon is moving in a circular fashion. That is why the moon is moving in a circular motion. Every body which is moving in circular motion have to have a centripetal force. So some or the other force has to act like centripetal. So we will say that the gravitational force is acting like centripetal. Okay, and we will equate them. Gmm by r square is equal to mv square by r, where small m is the mass of moon, v is the velocity with which moon is moving, r is the total distance between this and this, that is the radius of the circle. So accordingly we can create the further conceptions. So I'm not going into that much detail, I'm just giving you an example. So centripetal force does not have its own existence. Some or the other force has to act like centripetal. Now what about the centrifugal? Centrifugal force is even more ambiguous. I tell you why. Number one, centrifugal force is a concept which IB does not like. It seems to be that IB does not want to teach you centrifugal. They want to keep you away from centrifugal forces. Because according to them, centrifugal force does not even exist. Okay. Because clearly, I cannot say that these two forces are technically cancelling each other. Because if they cancel each other, then even then there will be no circular motion. So technically, they are not even cancelling each other. But there are some special cases we will see, just like the vertical circle, or like death well, some very good examples, very good numerical part. That becomes very, very easy if we learn from the centrifugal point of view. Although the magnitude is the same, all the equations created will be same, but if you keep on using the centripetal force only, there are many questions that you would be highly confused, like what the hell is happening in that question, and you will not be able to understand what is happening. So centrifugal concept becomes very important, like imperative in couple of situations. So, my humble advice to you is that as a student of physics, do not overlook the concept of centrifugal. But yes, as a student of IB, don't write it anywhere in your examination. Okay, don't talk about it. Wherever you want to write centrifugal, just centrifugal is only for your rough work. Okay, and wherever you want to write centrifugal, you just write centripetal and everything will fall in place. So don't show IB that you are using the concept of centrifugal, but as a student of physics, you can use the concept of centrifugal. I will show you some examples in coming time, and I will clearly show you how practical it is to use the concept of centrifugal. Why we cannot overlook this, I will show you that. Okay, dear students, so this is everything about the centripetal and centrifugal forces and about the relation between frequencies and angular velocities. So in this video, I think like this is a very important part that we have covered. Please do not forget this thing. If you say that this like you are not becoming good with this topic, please watch the video couple of times. Okay, like 2 3 times you will watch this, and then everything will fall in place, no problem. Okay, dear students, so this much is enough for this video. Please share the video with all your friends. Tell them to join the YouTube channel. Okay, then after this, we would be moving into the dynamics of translational motion. That is, we would be moving into forces. Okay, all the best. Bye. See you in the next video.